service providers continue to face new challenges.
Service providers are now being asked to provide more and more bandwidth to the end user while actually not getting any higher revenues.
Everybody is trying to push the ARPU up, and if ARPU is not going up, then where do you get the investment from?
That's Prakash Daga, Director of Product Management in Cisco's Mass Scale Infrastructure Group, formerly called Service Provider Routing. Market research shows that network traffic will continue to see a compound annual growth rate of 30% or higher, with more devices connected and more content being consumed. Services like video, gaming, virtual and augmented reality, all creating a huge surge in traffic with a direct impact on infrastructure. I've seen estimates that service providers will need to move 11 times more traffic per dollar of infrastructure investment in 2022. Plus, network demand has further exploded thanks to bandwidth demands created by everyone working from home. So to remain competitive, service providers are looking to hit at least 3 goals. 1, ensure networks are meeting these growing demands. 2, create new revenue-generating services. It's interesting. And the third, which is always on the list, lower costs. And that, of course, includes OpEx and CapEx.
Service providers need to be able to sell the differentiated services to be able to make that higher revenue, right? Which means they just can't do it with the existing infrastructure. They need to invest in their infrastructure, bring new products that can actually support this higher bandwidth requirement.
There's immense focus on streamlining last mile access between customer and services. Be it in transportation industry, e-commerce industry, hospitality, FMCG, most of these industries have found a new mojo with ease of operation of last mile access. Right? Telecom industry is no different. It's going through very similar phase. That is, how do you effectively connect consumer to the services? This is gaining importance now because of the expectation that 5G will bring a lot of new revenue generating services in future. The way these are connected to the backbone network will have immense impact on the competitiveness of the service provider. If one looks at the model of some recent greenfield operators, they are running their network at much lower cost per bit and hence are fiercely competitive while being profitable at the same time.
They have been hearing this term software-defined network, SDN, all along, which means they have been trying to create a lot of orchestration and a lot of higher level complexity on the overlay. But now they are realizing that if they still operate as multiple domains, like individual domains on their underlay, which means their access is built with separate network protocols, and their core network has some bunch of protocols, and their data center has totally different protocols, working in silo, they are unable to build an end-to-end story programmability, which hampers their time to deploy a new service. It could be a large enterprise or service provider.
Spinning up a simple service suddenly becomes a challenge due to all the operational tasks required.
So one major common thing that we see is, how can I simplify the operational things that I have? Just work with minimal number of technologies. So it's truly an SDN thing. So I can easily program, build any kind of orchestration on top of it.
Sounds like there's a need to simplify.
Now they get that SDN is required. Now they want to make sure the next set of investments and the next set of things that they build is actually catering to that.
In the post-pandemic world, you would see many residential environments looking for enterprise kind of connectivity. Hey, I really need an enterprise class service because now my home is my office.
When we talk about access, it actually refers to a few verticals, right? So it's the carrier Ethernet access, the business Ethernet. We had the mobile backhaul, or the fiber to the home, or FTTX kind of solutions we have. Everything has a set of technologies and all those things that goes in. We want service providers to think of a newer possibility wherein they can use a single set of access solutions, build an end-to-end story, have the same XR operating system that we are talking about, get the sophistication all the way to the access, at the same time be able to build this more complex solution, so they don't have to have this individual silo networks, making their operators' life easy. And we are bringing that intelligence all the way to the edge.
We've built this 500 series, which gives you right amount of bandwidth options at the right price point. The benefit of XR system and providing you at a cost point, along with the timing and the security capability which we are bringing in, it all comes together right now.
Welcome to the Explainers podcast. My name is Robb Boyd. On this episode, we are diving into the access network as we explore long overdue convergence. The move to 5G is a big inflection point where Cisco is now well positioned to deliver on seemingly incongruous goals to simplify the network so that it can be easier to launch new services. Well, the route for doing this? The new iOS XR-based NCS 500 series routers.
So a couple of years back in 2018, we started designing and launching our iOS XR-based products.
Sairam Potnaru is a product manager with Cisco's Mass Scale Infrastructure Group.
Our first product was March of 2018, which was called the NCS 540. Now that NCS 540 series has grown to have 10 different variants. All the 540 variants are 1RU boxes. They're specifically designed to deliver 5G services and applications that require low latency, and they're all temperature hardened. So they're suitable to be placed in any location. In any harsh environment, you can place a 540 device and it'll work.
You know, it's rare that equipment used in the last mile is going to have any kind of environmental enclosure like we might expect with network equipment. But I wanted to understand what this really means.
Yes, so there are two levels of hardening. One is the temperature we support. The device will work up to 65 degrees Celsius. So that is the level one. Level two is, along with that, you also have a conformal coating. Protect the device against the environment, not just the temperature. It could be smaller things like corrosion and chemicals and whatever. So it gives you that extra layer of protection. And this becomes a standard requirement for some of our customers in Australia or in India, because there's no choice, right? You have to put the device closer to the end user, which means you have to put it in locations where it's probable to fail unless you have this coating and extra protection.
So this NCS 540 is what we call a system on chip.
This is Akshay Kumar. He's a technical marketing engineer for Cisco's Mass Scale Infrastructure Group.
The basic idea in this platform is it is having the same set of ASICs, which means we can enable similar functionality as we can do in a core NCS 5500, all the way till the access, all the niche features and functionalities, the throughput and all the other features set here. The older generations of ASR 900s and all the other platforms, we are making sure that we are backward compatible with all the features that customer used to run. We are also compatible with the end-to-end story. So all the features that you can run on your core network today, you can run it all the way to the access. So if they want to, deploy an end-to-end service, they can do it end-to-end that way.
Sounds like a bit of a balancing act.
Basically, our NCS product family, the 540s, the 560s, and the 5500s, they're all part of with the Broadcom DNS ASICs, the Jericho Plus. What this means is we are taking this merchant silicon and we are using the XR operating system, and we are trying to build some creative solutions for different sets of use cases.
They're designed for universal applicability, which means they can support your service provider use cases, the mobile backhaul, carrier Ethernet. But on the other hand, they can also be used for your government providers or your industry providers, right? And they can cater to their requirements also.
So as I understand it, the NCS 540 has two notable distinctions as being both the smallest iOS XR router ever, as well as the most inexpensive. Yet it still supports thousands of features. I mean, this fixed line of 1RU boxes stands tall. Side to side or front to back airflow, low power consumption, less than 200 watts on average, versatile Ethernet options from your 10100, 1000 meg to your 110, 25, 40, 100 gig, low latency forwarding at less than 10 microseconds, and the latest in frequency and time synchronization, which of course is critical for this part of the network with 5G. Now, the NCS 560 was designed with a different set of objectives, yet complementary to its 540 peer.
Now, NCS 560 is a fully featured modular box designed specifically for aggregation and pre-aggregation roles to deliver converged mobile, residential, and business services for applications.
560 is more of a multi-RU chassis that has some multiple route redundant processor, the RPs, which gives you some high availability and all that. But again, this runs the Cisco operating system iOS XR, just like the NCS 540. And it can also, give all this timing benefits and all those.
You could start with as low as 200 gig, which means you take only a couple of IMs or a couple of line cards, and then you can, based on your requirement, grow all the way up to 800 gig. So there's a lot of flexibility in how you want to buy in, start using that box. You don't have to use everything on day one.
Two NCS 560 chassis to choose from here, a 4RU and a 7RU. Akshay briefly mentioned the high availability architecture, which helps support ISSU or in-service software upgrade, fully redundant control and data planes, where control planes are kept in sync, allowing for stateful switchover. And these all become important capabilities, of course, across the variety of use cases that these boxes enable.
NCS 540 and 560 series would work for access, pre-ag, and aggregation roles, and which in terms of use cases, they would cater to your mobile backhaul, your carrier Ethernet, your front haul, FTTX, enterprise use cases, and any kind of 5G mid-haul, backhaul, front haul use case. Obviously, 540 and 560 are the latest generation boxes with higher scale and higher capacity, which means they can also support your converged SDN transport kind of a solution. They can work as one box that caters to your both fixed and mobile traffic.
So now it should become obvious that the two series of 540 and 560s are designed to be unique for their role, flexible in their placement, yet consistent enough to work seamlessly as part of a larger Cisco network wherever needed.
All the platforms that I'm mentioning here, the name dropping that I'm doing, is all iOS XR software. So that's the cool part. Like they are able to work with that seamlessly from all the way from core to on the access side here.
The hardware options are diverse enough to be deployed within existing operating networks, supporting all the varieties of services that have sprung up over the years. These same platforms would then form the foundation for this promised world of simplicity and automation. To understand how this would work, we need to explore the architectural expectations and the required protocols. But first, let's explore the operating system making its first appearance in the access layer for Cisco.
Yeah, so here's what we've done. We've optimized XR without losing its functionality which it provides and breadth of goodness which it brings in, right? We've optimized for deployment which is access oriented. The footprint required is very small, and then we've used XR's performance, high availability, security, feature flexibility, etc. Bring all the goodness of XR into an access network. There's humongous amount of work which has gone in for us to create a form factor for XR which is conducive to access network, and also amenable at a price point which makes us very, very competitive.
We have been using this iOS XR operating system more than 10 years now in the service provider successfully. So we have done a lot of core and aggregation deployments with our ASR 9000s, the CRS platforms, and also the NCS 5500s today. And with all these platforms and the solutions that we have built, the operating system by itself is more SP ready than any other operating system in the market today. It has all the rich features that is capable of getting any kind of service that a customer wants. The benefit of getting that all the way to the access now is now a service provider can think of a lot of sophisticated, or the complex stuff that they can build for their diverse customer base, the services that they want to build, because now this operating system gives them the strength to get into any levels that they want. If they want to build a end-to-end layer 2 service, the same operating system that's going to be on the access is going to be running all across, throughout from the aggregation core everywhere. So if that's the way they are building the network, it's going to be very easy for them to manage and deploy.
When you say very easy to manage and deploy, I have to think this becomes part of the formula for reducing OpEx costs.
With our iOS XR, we can help the customers set up these devices remotely, zero-touch provisioning and other functionalities that we have. This helps the customer in not just setting up, but also going forward managing the devices from remote. You are reducing their operational cost for the customer. This is all done through our software, and it starts with having visibility into the network, right? Before one drives the automation into the network, you must know the current state of your network. And this is done through what we call as telemetry. And iOS XR is leading the industry in terms of telemetry in the network operating system.
So iOS XR is also laying the groundwork for a more automated system reaching all the way out to the wild parts of the access network, which makes me think of the kind of hardening we would expect, not related to temperature or moisture, but security.
The software comes in with multiple layers of defense, and hardware itself has a chip called Trust Anchor module that ensures that your hardware is always trusted. So when the customer is buying your iOS XR based product, they can be sure that they are getting a robust, secure product.
iOS XR is a modern modular operating system offering more resilience than its predecessor, and this opens up even more opportunities.
So in addition to the features and functionalities that are inherently available in the operating system already, customers can also do some additional, cool features, or, add some third-party containers if they need to, do some additional computation or functionalities there too.
Cisco iOS XR's app hosting capabilities become an enabler for far-edge serverless computing. And you think of all the low-footprint use cases leveraging these native Docker containers. You're already networked. There's an established root of trust in the hardware, and you're not limited to Cisco here as third-party app hosting is supported. Okay, so we have these flexible hardware options all running the same iOS XR operating system end to end. And this seems to be, of course, quite supportive of the simplification goals that we established at the onset. There does remain a few key ingredients as part of this convergent story in the area of transport protocols and service provisioning. So let's start with segment routing.
We need a certain set of transport protocols to make sure that we can enable some end-to-end services as a service provider. So traditionally, these protocols used to be an IGP like OSPF, ISIS, and also we need some way of distributing labels across. And that protocol again used to be a label distribution protocol or the LDP protocol. And in addition to that, we may also want to do some traffic engineering and all that, which again demands one more protocol like RSVP, which is the reservation protocol that we have. So now this resources and reservation protocols, this LTP and IGP is still not going to cut it. Like we also need few more set of protocols if they actually want to do some true layer 2 services, layer 3 services and all those. So now if you think of the number of services in this newer 5G era, when they are going directly business to business with this newer enterprise customers, that's going to be too many number of services that they want to spin up at every time. And although they have all the sophistications on a very high overlay, that underlay is still not mapped properly. It is still running the traditional multiple protocols that are not exactly synced with each other. So if certain protocol breaks, the other protocol needs to wait for sync and all those. So these are all like some complexities and cumbersomeness that has been traditionally a pain for us.
How does segment routing address this complexity?
The first major thing that we are doing is on the transport level. You just need a single protocol like the IGP, whether it's OSPF or the ISIS protocol. Mm-hmm. That's going to be the same protocol that's going to advertise the IGP prefixes and all those that it used to do. And it will also be able to distribute the labels on the same way and make sure everything is synchronized. On top of that, we are now being able to identify all these nodes and make sure that there is no state requirement on each and every node. So if I want to spin up a new service, I don't have to touch every single node like my core nodes and all those things.
So as a service provider, this means
I can spin up a service with minimal touch points. And I know that if I have this certain protocol running like segment routing running end to end, and if I push a certain label stack from this side, it's going to take that exact same path. So I'm getting the traffic engineering that I used to need. And I'm getting all this, different ways of finding my own path and all those things. So there are some newer way of programming my network that is inherently possible with segment routing, which was not even possible before, and with minimal, protocol administration that I need to do.
This is the simplification needed for end-to-end automation, controller overlays and such. So where does EVPN fit?
So when you think of services, although we have different verticals like business Ethernet, carrier Ethernet, mobile backhaul, and all those things, mm-hmm. Essentially the number of services that they actually need to build are pretty similar, like the kind of services that they actually spin out. It could be a layer 3 services, as we call it, like the virtualized layer 3 services or the layer 3 VPNs, as we call, or the layer 2 VPNs, which could be a point-to-point, point-to-multi-point, or a multi-point to multi-point. So there could be like different variations of it. With EVPN or the Ethernet VPN, we are able to build a simple control plane, the BGP-based control plane, which is so the EVPN itself is not a service, but it's more of a framework that can let them provision different number of services. So if they want like a layer 2 VPN point to point and all those things that we talked about, they can still use the simple EVPN framework to deliver all these services.
Instead of stitching one protocol into another one and making it more and more complex, if you move everything to EVPN, it allows the customer to use one simple and common BGP control plane across the network and simplifies the actual configuration and for the customer. So it makes it easy for the customer to deliver these services and to manage these kind of networks.
So when you think of someone who is going to be on the overlay, on an automation perspective, doing some orchestration, now they don't have to think of too many domains to stitch and then too many protocols to work with, but it is just a simple IGP and a single IGP protocol, which also can inherently do the segment routing transport, and the BGP protocol, and the EVPN is just an address family that's turned on. So although there is a lot of sophistication to what it can build, the actual number of node knobs that they actually need to know to actually turn on the solution is very minimal, and that's the reason why it's getting more attractive.
Beyond making all the usual stuff much more simple, does this combination at the access layer bring anything new? Okay.
So from a service provider perspective, in a very simplified world for them in for future, they'll be thinking of a very simple architecture, like they have a segment routing for the transport and an EVPN based architecture for their service provisioning.
A simplified architecture that not only supports existing use cases and ongoing operational models, but may also enable even more?
If you think of an multi-point service like the ELAN service, as we call it in the MEF Metro Ethernet Forum thing, or the Carrier Ethernet, these ELAN services, there are few challenges. Like you cannot build like multi-homing solution if a same end user is trying to connect to the service provider from different nodes if they want to have a redundancy, like a multi-homing. Right. Then in such solutions, there is no possibility today to avoid some kind of a simple looping. So these are all things that we think, okay, it should be possible in the protocol, but it's actually very complex to achieve in the traditional way. But in the EVPN solution, it's really cool to do, what we already do, but to do something really new, like multi-homing, which was not even possible, it really does, really well. So it's only possible with EVPN to do such things, which was not even possible before. So yeah, it's not just a simplification automation that I was talking about, but also some newer possibilities that they cannot even imagine in the traditional world. That's also coming in picture now.
SR is nothing but a much better version of MPLS that came 20 years back. It can do whatever your MPLS could do. It does it better. It does it simply. That also becomes an additional advantage because even our access products support SR EVPN.
And we are bringing all this rich experience and all the feature set all the way till the access. So that's the benefit here, like segment routing and EVPN, which will make sure you can enable all these services with a simple orchestration that you can do. At the same time, you're getting all the flexibilities that you used to have on the access. Two great stories here, like how on the same and the simple operating system end to end, we're able to get sophisticated line of all the access that we need.
All right, we have introduced the NCS 500 series, covered some details on the various models available, and dug into the benefits of segment routing and EVPN. All of this is to say, of course, that these routers are ideal for getting rid of all the extra protocols you may have accumulated, plus, for many of you, extending your core network in a way that supports more automation and an easier flexibility for a variety of new services. Well, part 2 builds on what we covered here to talk through the architectural changes driven by 5G, yet still fully compatible with a slew of new non-mobile services, all from the same end-to-end network. So please join me for the rest of the conversation in part 2.
Like we do it, 'cause no one can do it like we do it, like we do it, like we do it.